In this lesson, we're going to learn how to factor what is called a difference of squares. So most of the polynomials we've been looking at so far have been in the form ax squared plus bx plus c, or some just x squared plus bx plus c. So we had three different terms. With a difference of squares, this quadratic expression is not a trinomial. It actually only has two terms, so it is a binomial. But there's still a squared term, so we have an x squared over here. So this is an example of a quadratic relation that can be factored still to two binomials. So a difference of squares, there's going to be two terms instead of our normal three. Each of the terms has to be a perfect square. So we have squared variables. X squared is a perfect square because x times itself, x times x is equal to x squared. And then 49 is a perfect square because 7 times 7 is equal to 49. And then the two terms have to be separated by a subtraction. So x squared minus 49 is an example that hits all of those things. So two terms only, the x squared and the 49. X squared and 49 are both perfect squares, so we can square root them. And there's a minus in between them. So we're going to look at how we can factor a difference of squares quadratic relation into two binomials. And it's a lot less work than our other factoring of simple trinomials. So all we're going to do is find the square root of both the first and the second terms. So in our example here, x squared minus 25. So the square root of x squared is equal to x, and then the square root of 25 is equal to 5. So that's the first step, find the square root of each of the terms. And then we're going to write the square root of the first term in the front of both binomials. So I have two sets of brackets, two different binomials that I'm going to have, and so the square root of x goes at the front of each. And then the square root of the second term is going to go at the back of both of the binomials. So 5 is the square root of 25. So x times x gives us our x squared. And to get to a negative 25, I need a positive and a negative 5. So a plus 5 and a minus 5. So this is going to give me x squared minus 5x plus 5x. So that's going to cancel to give me 0x, which is why there is no bx term in this. And then plus 5 times negative 5 is equal to negative 25. So that's how I get my x squared minus 25. So we're going to separate one binomial with a plus, and we're going to separate the terms in the second with a minus. So we have the exact same things written, x and 5 in both, but one of them is x plus 5 and the other is x minus 5. Because we have the exact same, our middle term, our bx, becomes a 0 because we have the same number as a positive and as a negative, so they will cancel out. So let's try a few examples here. So we have r squared minus 9. R squared and 9 are both perfect squares, so I'm going to write equals, and my first bracket I'm going to start with an r because r is the square root of r squared, and the square root of 9 is 3. So my two brackets are going to have r and 3, and one of them needs to be positive and the other needs to be negative, and that's it, I'm done. So I can check. R times r is r squared, r times 3 is negative 3r, and 3 times r is positive 3r, so minus 3r plus 3r is 0r, so I don't need to write it. And then 3 times negative 3 is negative 9. So our next one is a squared minus 100, so the square root of a squared is a, and 100, the square root of that is 10. So I have a and 10, and then one needs to be a plus 10 and the other a minus 10. So here, square root of h squared is h, and the square root of 1 is 1, so 1 will be a plus 1, and then 1 will be a minus 1. So these ones are very quick and easy to do. Now, we might have actually a number in front of our variable, so instead of just b squared, we might have 9b squared. And as long as the number in front of our variable is also a perfect square, then we just do the same thing. So the square root of 9 is 3, and the square root of b squared is b. So 3b times 3b is equal to 9b squared. And then the square root of 4 is 2, so we'll make this one a plus, and then we have 3b minus 2. So 3b times 3b is 9b squared, and then I'm going to have minus 6b plus 6b, that will cancel, minus 4. So same process, we're just also square rooting the number that comes in front of our variable. So in this next question, the square root of 4 is 2, and then the square root of f squared is f. Then I'm going to have a plus 9, and then 2f minus 9. 9 is the square root of 81. Over here, the square root of 16u squared is 4u, and the square root of 49 is 7, so I have a 4u plus 7 and a 4u minus 7. And then one last type of question over here. 2 is not a perfect square, but 2 and 8 can both be divided by 2, so I'm going to start by common factoring. So 2p squared divided by 2 is just p squared, and negative 8 divided by 2 is negative 4. Now when I look at these, p squared is a perfect square and so is 4, and we're separated by a subtraction, and there's only 2 terms in here. So what's in this bracket I can now factor out into 2 binomials. So the square root of p squared is p, the square root of 4 is 2, one is a plus 2 and one is a minus 2. 5m squared minus 80. So both 5 and 80 can be divided by 5, so I'm going to factor that out. And 5 times 16 is 80. So 1m squared and 16 are both perfect squares. So m plus 4 and m minus 4. So the square root of m squared is m, and the square root of 16 is 4. One's plus, one's minus. And then one last example here. So I have 12k squared and 27. So I have my square here with the k for my variable. I only have 2 terms and I have a subtraction. Now 12 and 27 are not perfect squares, but I'm going to see if I can factor a number out. So 12 is even, it can be divided by 2, 27 is not, so we can't factor 2 out. 12 can be divided by 3, so can 27, so let's try to factor that out and see if we're left with perfect squares. So 12 divided by 3 is 4, so I have a 4k squared left. 4 is a perfect square. And 27 divided by 3 is 9, and 9 is also a perfect square, so this will work. So equals 3, we'll rewrite that, and 4k squared minus 9, the square root of 4k squared is 2k, and the square root of 9 is 3, so I'll do a plus 3 for the first one, and a minus 3 for the second. Now, I have been putting a plus in the first bracket and a subtraction in the second bracket consistently throughout. It doesn't really matter. As long as one of them has a positive and the other has a negative, then you have the correct answer. The order, because all of this gets multiplied by all of this, the order does not matter in multiplication.